All right, we're picking up from where we left off on Bohr diagrams. Well, the last thing that we went over was some things about protons, neutrons, and electrons. And I told you could work on questions 1 to 4 on your assignment. And then this other stuff would be covered in the last part here. So we're going to go over Bohr diagrams today. And if you remember, Bohr was one of the people that came up with one of the atomic theories that led to what we know today. It says Niels Bohr suggested in his atomic model that electrons exist in fixed energy levels that surround the nucleus of an atom. We can represent the arrangement of electrons in these energy levels using a Bohr diagram. So it says the innermost shell can only hold 2 electrons. So you see this innermost shell, it's only holding 2 electrons. Each outer shell can hold a maximum of 8. So this next shell, you can see it's got 8. And then the last shell could hold 8, but this one doesn't have 8 to put into that shell, which we'll get to when I do some examples. Elements with the same number of electrons in their valence shell display similar chemical behaviors. If a atom has 5 in its outer shell and other one has 5, they're going to do or have certain characteristics to them that are similar between them just because of the amount of electrons in their outer shell. So this is a Bohr diagram that can also be drawn as a simplified model. So there's another simplified model of how we can do Bohr diagrams, and you see that here. So what they're doing is they're drawing the outer shell, and then they're drawing the nucleus with the protons and the neutrons, and then they are drawing each of the shells, just writing the number of electrons that are in each of the shells. Sorry, I had to close the door. So the first shell has 2 electrons, and that's represented here. The second shell has 8, so that's the second shell here. And then the last shell has 6, so farthest away from the center is the 6 electrons. All right, so right here, 16 represents the protons, and 16 with a 0 represents the neutrons. And then this S is obviously the atomic symbol for sulfur. So we're going to do some practice examples to show you how we do this. It says draw the Bohr diagram for an atom of nitrogen. So what I'm going to do is I'm going to go back out here so I can draw. So what it said is should be able to draw here, maybe not. So it said we're going to draw nitrogen. Nitrogen is the letter N. Not sure if we can go down any further. If I start drawing, this maybe not be the best place to draw this. Just let me open a new note. This is the new note. Okay. All right. So nitrogen is the Bohr diagram that we're going to write, and our symbol for nitrogen is N. For our Bohr diagram, we have a center, which is known as our nucleus. And in the center, we have the amount of protons, which are positive, and the amount of neutrons, which are neutral. All right? So for nitrogen, we got to look on the periodic table to see what the number of it is. And if we look on the periodic table, we can find, maybe I can show you the periodic table. Why don't I do that as I'm in this? So if we look at the periodic table, and nitrogen there is number 7 in the periodic table. So that means that it has 7 protons. So it's always going to have the number that it is in the periodic table. For neutrons, we have to do a calculation for this, if you remember. Neutrons is your mass minus your protons. And for nitrogen, if we look at the periodic table, the mass is 14 and the protons is 7. So 14 minus 7 gives us 7. So our neutrons is also going to be 7. All right? So that's that part. I'm going to erase this just so we have space. So now we're back to here. Now we can put our circles for nitrogen. And I'm going to go to the camera again. So if we look at the periodic table, we look at nitrogen. To figure out how many circles we need in the periodic table, or sorry, in our Bohr diagram, we can look at the periodic table and we can basically count from the top of the periodic table at hydrogen there, and count from hydrogen down, so down the periods, down the columns. And we count from the top to where our element is, which row it's in. And we can see nitrogen is in the second row. It starts on hydrogen, then the second row, lithium, beryllium, boron, carbon, and nitrogen. So it's over in the second row, okay? So if it's in the second row, what that means for us is that we have 2 circles. So each circle around, or shell, around your Bohr diagram is represented by the rows, columns, it's rows of the periodic table. And those rows are called periods. I don't know if it says it on your periodic table, but it does mine. So as you go down, these circles or shells, they are represented by the periods, or these represent the periods. So nitrogen is in the second period down, which means we have 2 circles around our nucleus. Then we are now putting in our electrons. And our electrons for nitrogen is 7. Because it's number 7 in the table, it's 7 electrons. So we put 2 in the first one. And why we do that, going back to my camera, is if we look at the first period, we see hydrogen and helium. So that's all we have in the very first period. So that first circle represents that first period or first row of the periodic table. There's only 2 elements in it, so it can only have 2 dots. In our second row, second period, we go from lithium all the way over to neon. And if we count from lithium to neon, there's actually 8 there. So it can have 8 electrons in it. So our first one, 2, our second one can have 8. But for us, we don't have 8 electrons. We only have 7 in total. 2 were put in the first one, so I sort of keep I like to keep a running tally on the side. So we had 7, we put 2 in. We put those 2 right here. So now what's left over is 5. So we've got 5 electrons left. So we would put those in, and it doesn't matter where you put them because they are floating around, moving around in that circle. So they could be anywhere at any time. So it's not concerning where you put them. Ooh, don't want to do that. I was going to try and get rid of the yellow. There we go. All right, so that is the Bohr diagram for nitrogen. That is how you do a Bohr diagram. All right, So let's go back to this and find out what the next one they want us to do. So it says draw the Bohr diagram for an atom of carbon. So we're gonna do carbon next. I'm just gonna scroll down a bit here and we can do this one on the bottom. So carbon, that's C is for carbon, that's the atomic symbol. And if we look for carbon in the periodic table, it's actually number 6. So if it's number 6, that means it has 6 protons, 6 electrons, and neutrons we need to always calculate by taking our mass minus protons. And in this case for carbon, our mass is 12 minus 6, because we've got 6 protons here. That gives us 6. So our neutrons are also 6. Okay. So that's that. So we've got all those pieces. So now we can draw our Bohr diagram. So we draw our nucleus first, that center. We put our protons and our neutrons. Our protons are 6 and our neutrons are 6. Sometimes I like to put a line through that so it doesn't look like 60. Some people also put like 6p and 6n. That's also right. It's whatever way you prefer. I'm not too picky on that. All right, so now that we've got our nucleus there, we can draw our electrons in. And remember, our electrons go in circles around the nucleus. If we go over to our periodic table, we see only hydrogen and helium in the first row, so we know there's at least one circle. Our second circle, we look over and carbon is in the second row of the periodic table. So if we're drawing the Bohr diagram, it only requires 2 circles. We see where lithium is, all the way over to carbon. And it's actually right beside nitrogen, which is what we did in our last question. So we have the same amount of circles as our last question. So I'm gonna draw the shells around. And then we have 6 electrons to work with. So again, only 2 can ever go in the first because that's representing the first row of the periodic table, and the first row only has 2 elements. And then the second one, because we had 6 and we used up 2, we still have 4 left. So the last circle is gonna have 4 electrons in it, okay? So those are just dots. They can be anywhere just because they're representing those electrons that are moving around in that area, all right? That's that. I need to go back, to the notes. The next one's asking us to draw the simplified Bohr diagram for an atom of potassium. And then the next one is phosphorus. So let's do that. So we're going to do the simplified of potassium. All right. So we need to know all the same things. We need to know our protons, neutrons, electrons, because they're all going to go into this diagram. How we do our simplified is we're going to draw our nucleus. It has the symbol for potassium, which is K. And then it's going to have our protons and our neutrons, just like the other one. And then instead of drawing circles with dots, we're going to have little shells divided by lines outside of that, but we'll figure that out in a second. So if we look at our periodic table to find out potassium is number 19 in the periodic table. So if I give you you can see it there. It's the fourth one down in the first column, potassium, K, and it's number 19. Okay. So that means that we have 19 protons and we got 19 electrons. Our neutrons, we need to figure out. If we look on our periodic table, the mass is 39. And then we need to minus our 19, which would give us 20. Okay. So that is our protons, our neutrons, electrons. So now we can plug those into our nucleus. So protons, 19, neutrons, 20. I like to put that line through just so we know. All right, so that is the nucleus, and then we need to represent each of these circles in these little lines, I guess you could say, or little divisions. So our divisions here, we've got 19 electrons to work with. So we put 2 in the first one, because remember there's always only 2 in the very first circle. So 19 minus 2, that gives us 17. In our second circle, it can hold a total of 8. So that's 8 that we're going to take away from 17. That's going to leave us with 9. The next circle can hold up to 8 as well. Just to show you I'm not making this up. So our first row only has 2. Our second row has 8 elements. Our third row has 8 elements as well. Then our fourth row actually has 18. But, so if we were going to draw something farther, it could hold 18, but for us, we're at the very first element there, potassium, so we are going to draw 4 shells, but in the last one, there's only going to be 1, because we've got 2, 8, and 8, so 9 minus 8 will give us 1. So our last shell is going to be 1 electron. Okay? So that's how we draw it. It's a little bit different. This might be a little bit harder. I don't know if it's harder or not. It's supposed to be simplified. But I mean, it's easy for me to see looking at this as opposed to counting dots. But it's totally whatever you prefer. I told the class that we honestly will never probably see these simplified ones after you do it in Science 10. The last one here that we're going to do is phosphorus. And we're going to do the simplified of this as well. So if we look at the periodic table for phosphorus, phosphorus is number 15. If we look at how far down it is, it's in, I believe, the 3rd row down. 1, 2, 3. So that means it has 3 shells. Number 15 with 3 shells. So why am I saying there's 3 shells? Because I want to be able to draw this. 1, 2, 3. So I'm leaving those 3 spaces. Phosphorus is P. Our protons and neutrons. It is number 15, like I said, which means it has 15 protons. Electrons will also be 15 because they're always going to be the same. And then our neutrons, that's one that we might not, it might not be 15. I'm just going to erase this out of the way. Our neutrons, they're going to be our mass, which is 31 minus 15, which would actually give us 16. Okay, so that the neutrons are 16, so when we draw that right here, we're going to write 16. Now we've got 15 electrons to work with. 2 always go in the very first. That leaves us with 13. 8 always go in the second. 13 minus 8 gives us 5. And then the last one, it could hold 8, but we've only got 5. So that's the end. All right, so we put that 5 right in there. This becomes our simplified diagram, and that's it. So you're gonna have some of these to try out when you're working on your assignment, and if you have any troubles, please let me know, because I can help you in any way possible. Also, there might be some videos that might show this, so I'll see if I can find any that might explain it a bit better than me. Here's some practice problems. It says, consider the Bohr diagram below. What atom does this represent? So these could all often be questions that you might get, where you're going to get the Bohr diagram and you're going to say what is it? So to be able to figure this out, our best bet is to look at this. 3 positives, 3 protons is what that means. So if it's got 3 protons, protons is always the same as the atomic number. So if we look at the periodic table and look for what is number 3 in the periodic table, that's going to tell us what element this is. Okay, so if I go to the periodic table and I look over here at number 3 there, the second one down under hydrogen is lithium. So lithium would be what our answer is here. Okay. Now consider the Bohr diagram below. What atom does this represent? Again, I told you the key here is protons. That's not the thing I want to use. Not sure why it's not coming up. Anyway, it's protons is what we want to use. It's going to erase it. Anyway, we want protons. So protons is number 11. I don't know why I'm not getting my cursor, but I can erase all these random things. There we go. So number 11 is our proton. So if we go to our periodic table and we look for number 11, we will see that number 11 is sodium. So number 11 is sodium, which means this Bohr diagram should represent sodium. I don't know why I can't write. They did a new update on my turning it on and off is not going to help. Anyway, so this is sodium. I can't write it for whatever reason. I'm not too sure. There we go. Wow. Technology is not always our friend. There we go. So that's sodium. So that's how you could have multiple choice questions on your test that would look like that. So I hope they're pretty straightforward and will be easy for you to understand. This last concept here is looking at ions. So I told the class the other day that there's certain atoms on the periodic table that can become, or they can have charges. And we wrote down on the periodic table some of those charges, or ones that we know. So we wrote them above the rows on our periodic table. So if you haven't done that, I'll show you how I want that. So if you look at my periodic table here, the very first row has a +1 above it. So you should write that on your table. That basically means that if these things ever have a charge, they're going to be a +1. The second row is +2, which means that, or 2+, that every time those had a charge, they would be a +2 charge. Looking over here, fluorine, that row, everything in that row has a -1 charge if it does have a charge. oxygen row, that has a -2, and the row with nitrogen, everything in that row would become a -3. And they're not always going to have a charge. You've just got to watch out to see if they have a charge. So calcium, if it has a charge, it would say it's something like that. Nitrogen would say something like that. Okay? You've just got to watch out for seeing that little charge that's a superscript, which is a little number above the symbol for that element. Okay? So ions that are atoms that have lost or gained electrons. So something really important about ions is that ions gain or lose electrons. So the only thing that ever changes in an ion is the electrons. I hope this makes sense because remember we just drew our Bohr diagrams and we drew those circles around and we've got electrons. And then those protons and those neutrons are in the middle. So the easiest thing if you're going to lose anything is those things on the outside. These outside things, those are going to be easier to lose. The things inside of you, not as easy to lose. This thing's going to be messed up again. Yep. All right. So that is that. I'm just showing you that. So ions, they gain or lose electrons. The protons will always stay the same. So if you see calcium 2+ or you just see calcium, they're both going to have 20 protons. They're not going to change. The only thing that's going to change is the amount of electrons. The electrons could change to something else. I don't know why this is doing this. It's got this like new thing on it that if you tap, you should be able to change your between writing and erasing. Doesn't seem to be working very well. So anyway, all of that goes. The point of this all is that ions can be positive or negative. The ones that are negative, those are called anions. And the ones that are positive, those are called cations. This little meme or whatever it is on the side here, it says cation, an anion that is positive in charge. So cations are positive. To me, I always remember cats are positive because I love cats. And negative is anions, and I think of ants. Like I hate ants and I love cats. So cats positive, ants negative. So whatever you need to know or to remember that's just a way I have remembered in the past. All right. So why is this all important? Well, we're going to do some examples here that'll sort of explain why we need to, or how we can figure out how many electrons are in each of these ions. So the first one here is sodium. So we're going to do sodium, calcium, chlorine. So I'm going to not go to that. I'm going to go back out here to this note, and we'll continue on the bottom here. For some reason, it works perfectly over here. Maybe. So we're going to do sodium, and this is on ions. Okay? So for sodium, the symbol of it is Na. And if we look in our periodic table at Na, we see it's in that very first row, and that very first row has a +1 charge. So sodium, it actually said it in the question as well, but sodium has a 1+ charge or +1 charge. So what that means is the overall charge of that atom is +1. So to do this question, what we're going to do is we're going to look at how many protons and how many electrons there are. And I'm going to tally those up, but we know that our overall charge is +1. So I'm putting this number down here. We have a +1 overall. Protons, if you remember, those are positive. Electrons, they're negative. So if we look at sodium in the periodic table, sodium is number 11. That means that we have 11 protons. I'm going to say we have 11 positives, okay? Negatives, we're not sure, because remember in atoms or in ions, the electrons will change. That's the thing that's changing. So that's what we need to find out. So we know there's always going to be 11 positives. How many negatives are there to get a +1 charge? Well, basically you can go just say in your head, 11 minus what gives you 1? And the answer here would be 10. 11 minus 10 gives you 1, okay? So that's how we figure this out. So the question's asking how many electrons are in a sodium ion. And the answer is 10. Okay? That's how you do that type of question. Okay, so there's more of these. It's on the very last slide. The next one's asking us calcium. So let's go down here and let's try calcium. So calcium is Ca on the periodic table, and it's in the row that's a 2+. Calcium, if we look it up on the periodic table, it's number 20. So that means it has 20 protons. Remember, protons are positive. Electrons, on the other hand, are negative. And all of those together need to give us a +2. So if we have something that is a +2, in our head we're going to need to go 20 minus what gives us 2. And the answer to that is 18. So if we have 18 negatives and 20 positives, 18 of those 20 are going to be canceled out. What's left over is 2. Okay? So the answer to this question, how many electrons are in a Ca2+? There's 18 electrons. All right. I hope this is making sense. Please let me know if it's not, and I can talk to you individually to help you out. We're going to do chlorine, and then we're going to do sulfur, and then we'll be done with this lesson. Okay, so let's do chlorine. And I'm just going to write sulfur way down here so I don't forget. So chlorine is Cl in the periodic table. It's in the second last row, which has a -1 charge. Everything in that row. I'm going to put 1 negative. If we look at chlorine in the periodic table, it is number 17. You can check it out if you don't believe me. And that means it has 17 protons, because it's always going to have the same amount of protons as the number in the periodic table. That's positives. Protons are positive. Electrons, on the other hand, those are negative, and we don't know how many we have of those. But we know from this little charge that our overall charge is -1. So in this case, we need to say, well, how many 17 minus what gives us -1? And if that's confusing to you, when I look at these ones that have negatives, you can think of, well, we need one more negative than we do positive. So if we have 17 positives, then we must have 18 negatives, because those 17 positives will be canceled out with the 18 and they'll be left over with one negative. So our answer would be 18 electrons. I think our last question was 18 as well, see? So 18 electrons there. Our last question is sulfur. Sulfur is S, and it's 2 negative in the periodic table. It is number 16 in the periodic table, which means it has 16 protons. Electrons, we don't know, but we know that the overall charge is -2. So for this one, again, we need to have 2 more negatives than we do positives. So if we have 16 positives, that means we need to have 18 negatives. And again, this means we have 18 electrons. All right. There might be a slightly easier way to do this, because if you notice, everything, all the negatives that we did that are in the 3rd row of the periodic table, they require 18 electrons. 18, gonna go to my camera here, is the number of argon. See argon here on the very end? So all of these, phosphorus, sulfur, chlorine, they all want to be like argon. If we go up the table, nitrogen, oxygen, fluorine, they all want to be like neon. If we were in the top row, everyone else wants to be in that row like helium. Okay, so these negative ones, they'll actually always have as many as this last one in the row. And these last ones in the row are called noble gases. They're like the coolest elements on the periodic table, and everyone wants to be like them. So if we notice the first question we did, it was negative. They all wanted to be 10 electrons. These ones wanted to have 18. So it makes it maybe easier there to see that they're always going to want to be like the noble gases there. These guys, the ones that were positive, the cations, calcium is 20, but it had 18. So these positive ones, actually, instead of going all the way over here and trying to be like the next guy, 36, these guys actually will go backwards. So calcium will go backwards, it'll go up one row, and what's the closest one? Well, that's argon. So calcium had 18. If we looked at potassium, it would also go backwards to be 18. If we were looking at magnesium, that one would go backwards to be 10. So they're always, these 2 rows, they're gonna have as many electrons. They're gonna try and be like the guy that was a couple behind them in the periodic table, okay? And this is gonna open up to our next lesson on the periodic table. We'll talk a little bit about the groupings and stuff like that. All right, so that's the end of our lesson today on ions and the atom, and you can finish up that assignment. You can submit it on the Google Classroom, and you can also take pictures of it if you have it on paper and send it to me. And let me know if you have any questions, and check the course outline for any sort of ways you can get a hold of me. All right, so have a great day.